Layer 2 solutions are built on top of the main blockchain infrastructure. They do not require changes to the base-level protocol. Rather, they exist simply as smart contracts that interact with off-chain software. Payment or state channels are one of the more established blockchain scalability solutions. The idea here is to use side channels or chains for processing transactions off the main chain. Once transactions on the side chain are processed and the state of the channel is finalized, it is written back on the main blockchain. In this way, a lot of the transaction processing load is outsourced to a faster side chain, thus minimizing the amount of total validation effort by miners. Here's a useful illustration to clarify this idea. Imagine that two friends go to a bar and open a tap. In this way, rather than paying for each round of drinks separately, their respective orders are recorded by the bartender and settled at the end of the night when the friends are about to leave. Similarly, when two parties make transactions between each other in a payment channel, they will not record each transaction on the main blockchain. Instead, only after they finish all their dealings on the side chain, their respective account balances will be recorded on the main blockchain. In a bit more technical terms, the process works along the following steps. First, a part of the blockchain ledger, including the account balances of the parties involved in the payment channel, is locked in a smart contract. This smart contract includes the agreement and business logic of transactions between the participants in the channel. Then off-chain transaction processing between the parties takes place. The state of participants' account balances is updated only between them for the time they use the channel. This allows any number of transactions to be processed without requiring registering transaction within the main blockchain, and it makes the process fast and scalable. Once the parties have finished their dealings between them, the payment channel is closed and the final state of their account balances is written back on the main blockchain. This is a very effective solution in rendering a faster and lighter blockchain network. Payment channels are a good solution for micropayments and Internet of Things transactions, among other applications. They can minimize the cost base of transaction processing on the network. Payment channels are used in the Bitcoin's Lightning Network and Ethereum Raiden network. On a side note, Raiden is the god of thunder from the popular computer game Mortal Kombat. Lightning networks provide a useful platform for lightning-fast transactions where participants don't need to open a bilateral payment channel with each person they want to transact with. Instead, the platform provides a network of such channels that reach everyone connected to it. Thus, a user just needs to open one channel to connect with the Lightning Network and then transact with anyone else connected to it. The Bitcoin Lightning Network has recently been deployed and is already operational. There are also some decentralized applications that use state channels to a great effect. Do you remember Funfair, the online gaming platform running on Ethereum we presented earlier? They have built state channels called Fate channels to enable fast and efficient transactions and facilitate scalability of their platform. Plasma. Plasma is a new concept introduced by Vitalik Buterin and Joseph Poon in a research paper titled Plasma: Scalable Autonomous Smart Contracts, published in August 2017. It is similar in a way to state channels, as it aims to build a platform for conducting transactions off the main blockchain while it's still connected to it. The novelty here is that Plasma allows for so-called child blockchains, attached to the main Ethereum blockchain through a set of smart contracts. Each child chain, in turn, can have its own child subchains. This architecture enables many complex operations to be done by smart contracts only at the child chain level, with minimal interaction with the Ethereum main net. In this way, the scaling of entire decentralized applications can be managed. With Plasma, we can avoid the replication of every single smart contract operation across all full nodes on the Ethereum network. This solution would spread around the workload of transaction processing and make the Ethereum network much lighter and more efficient. In Plasma, child blockchains can have their own consensus algorithm, which can be different. Plasma also provides a security mechanism which guarantees that users can always withdraw their funds and assets from the child chain to the main Ethereum blockchain. For securing plasma chains further, another mechanism can be deployed whereby validators or block producers on child chains commit deposits in a smart contract on the Ethereum main net, which binds them to play by the rules at the peril of losing their deposit. If we compare the state channels technology to the plasma technology, state channels should still allow faster and cheaper transactions, while plasma should allow more functionality and flexibility. Both technologies can actually be combined with state channels built on top of plasma chains. Truebit. Truebit is a new technology introduced in a research paper published in November 2017. It is designed to facilitate very complex calculations on the Ethereum blockchain. This is different to increasing transaction throughput, which scaling solutions like state channels and plasma aim to resolve. To understand the use case of Truebit, we need to keep in mind that computations performed on the main Ethereum blockchain are costly. Again, this is because they are processed by all full nodes on the network at the same time. To compensate miners for their computational work, Ethereum has a reward mechanism called gas cost, which is essentially transaction fees paid by the users who call transactions. Moreover, each Ethereum block has a maximum gas limit that sets a cap on how much total computation can be done by all transactions in a block. Therefore, some tasks that are too computationally intensive cannot be included in a block, even if they were the only transaction for that block. For example, a smart contract running on Ethereum may need to verify that a transaction has been done on another blockchain, such as Bitcoin. This may be necessary for some applications that want to connect the two blockchains. Such verification could be a too big computational task to be performed on the Ethereum main net. In this case, Truebit can help. It essentially outsources the work on performing the verification to a third party. To guarantee that such third parties act in good faith, they are required to lock in a deposit in an Ethereum smart contract, which would be foregone if their job is not done properly. We call this party a solver. To enforce correct operation, the scheme makes use also of another third party which checks the work performed by the first one and has monetary incentives to do this properly. We call this party a challenger. In case there is a difference between the results obtained by the solver and the challenger, they are required to identify the exact operation which causes the disagreement. This should narrow down the computational work to a small task that can be performed on the Ethereum main net, and that would clearly show where the truth is and which one is the correct result. Truebit can be a useful solution to allow complex machine learning algorithms to run on the Ethereum blockchain, thus enabling artificially intelligent smart contracts that can be used to run decentralized autonomous organizations. Remember that we covered this topic in our Ethereum section. Finally, we should note that in all systems there is an inherent trade-off between scalability and speed on the one hand and security on the other. For high-value transactions, perhaps it will always be better to process them directly on the main blockchain for the sake of security. Small-value transaction may be better served using the off-chain scaling solutions we discussed. The next generations of blockchain technology will probably implement combinations of the solutions presented here in order to address the scalability issue.